Let's take a look at the worksheet that I left for you to do last Friday. So go ahead and have that up, and you're kind of checking your answers, but you're also putting the answers down and figuring out how to do the problems that you weren't sure about. On number 1, we've got a rectangle that has one vertex in quadrant 1 on the graph of y equals 10 minus x squared, another at the origin, one on the positive x-axis and one on the positive y-axis. Just as a sketch over here, 10 minus x squared means that we're going to have a parabola opening down, looking something like that. Now, it's saying that we're dealing specifically with a rectangle in quadrant 1. So just in quadrant 1, a point on the graph, a point on the positive y-axis, a point on the positive x-axis, and a point at the origin. Okay, so here's our rectangle here. And since it's just in quadrant 1, we can call the width x and the length y. So normally, where we write y equals length times width for the area of a rectangle, we're going to say that a equals x times y. Now we want the rectangle to be a function of just x, so we need to get rid of y. We're going to replace y with the equation 10 minus x squared. That's the equation of the parabola that was given to us earlier on. At this point, x is the only variable in the equation, so you can leave it written like that, or you can write it as a of x equals 10x minus x cubed. So there's your area, or your function, of the area of the rectangle as a function of x. Now part B is asking you to find the largest area that can be enclosed by this rectangle. So we're going to graph this equation on the graphing calculator and look for the maximum. So on your graphing calculator, 10x minus x to the third. It is a cubic, so we're going to expect it to look, kind of have some curves to it. Since we're looking for a maximum, I can see a maximum is happening up here. Right there. I'm going to change my window just a little bit so I can see that high. I'm going to go up to 20. And then I'll let my calculator do the work for me. Second, trace, 4. Make sure you're on the left side of the hump. Then make sure you're on the right side. Okay, so I got an ordered pair. That's 1.83, 12.17. So for that ordered pair, we got our max to be at 1.83, 12.17. Oh, okay, it disappeared. So 1.83, 12.17. We talked last week that an ordered pair is always x, y, but our equation does not have a y in it, so what's secretly in the y spot is that a. Okay, so this is x, a, and if they're asking us for the largest area, that means that they want this second value here, so the largest area possible is 12.17 units squared. So that's your answer for part B. Taking a look at number 2. Okay, so a semicircle of radius r is inscribed in a rectangle so that the diameter of the semicircle is the length of the rectangle. And this picture was drawn specifically so that the radius was going not to a nice corner. Okay? So from here to here is r, but it's also true to say that straight up and down is r, which you'll notice is the length of your rectangle. And also from the middle to the edge is r on both sides, which means that the width of your rectangle would be r plus r, which is 2r. So on part A, where they want us to express the area as a function r of the radius, we know that the area of a rectangle is length times width, but in this case, the length is r and the width is 2r. So then the area as a function of r is going to be 2r squared. Express the perimeter P of the rectangle as a function of x. Usually perimeter is twice the width plus twice the length. Again, our width is 2r. Our length is r. So if you have 4r plus 2r, your perimeter is going to be 6r. So P of r equals 6r. Whenever they're asking you to write a function, they're just asking you to write an equation with one specific variable in it. Taking a look at number 3. Let P be a point on the graph of y equals x squared minus 8. Express the distance from P to the point 1, -1 as a function of x. So they want us to use the distance formula, which we should be pretty comfortable with, but just writing it up here so we don't forget it. The square root of x2 minus x1 squared plus y2 minus y1 squared. And you have to have two ordered pairs in order to use the distance formula. The two ordered pairs that we have are x comma y and 1 comma -1. Plugging that in, we've got the distance equals the square root of x minus 1 squared plus y plus 1 squared. We want this to be a function of x, which means the only variable that we want in this equation is x. We need to replace y. This y right here can be replaced with x squared minus 8. So now our equation is going to look like d equals the square root of x minus 1 squared plus, open parentheses, instead of y, we'll write down x squared minus 8, but you're still going to have that plus 1 in there as well, squared. And then we'll do some algebra. Okay? D equals the square root of, when you FOIL out a binomial, you get a trinomial. X squared minus 2x plus 1 plus. Now underneath here, that's the same thing as saying x squared minus 7 quantity squared. Again, it's a binomial. You FOIL it out, you get a trinomial. X to the 4th minus 14x squared plus 49. Combining like terms, d of x equals the square root of x to the 4th minus 13x squared minus 2x plus 50.
Attention please, there's an NEA meeting going on in Andrea Frederick's room in the elementary. Thank you.
So at this point, d of x is the only variable, we're done. Now we're going to use that formula in part B. What is d if x equals 0? So you're being asked to plug in 0 for all of those x's, which is great because the 4th root of 0 is 0. 13 times 0 squared is 0. 2 times 0 is still 0, plus 50. So we're looking at the square root of 50, or 5 square root of 2. Then on part C, plugging in -1. So you're taking the square root. -1 squared is 1. -1 squared is 1 times -13 is -13. -2 times -1 is positive 2, and then plus 50. So when you combine all of those, you get looking at the square root of 40, which is going to be 2 square root 10. Let's take a look at number 4. Okay, so let x comma y be a point on the graph of y equals the square root of x. Express the distance d from that point P to 7 comma 0 as a function of x. Again, we're doing distance, so we're going to use our distance formula. Our two ordered pairs are 7 comma 0 and x comma y. Setting up our distance formula, x minus 7 squared plus y minus 0 squared. So d equals the square root of x minus 7 squared plus y squared. X is the only variable we want in the equation because it says as a function of x, so we can replace y with the square root of x. Our equation will look like d equals the square root of x minus 7 squared plus, now instead of y, we're going to write down the square root of x squared. A binomial squared becomes a trinomial, so that's going to give us x squared minus 14x plus 49, plus the square root of x squared. Well, squares and square roots cancel each other out, so that's just going to leave you with 1x. Combining like terms, d of x equals the square root of x squared minus 13x plus 49. X is the only variable in your equation, so you know you're done. On part B, find the shortest distance possible. Think max or min. So that should have told you, hey, go get a graphing calculator. Let's graph this thing and see what it looks like. So we're looking at taking the square root of x squared minus 13x plus 49. Graphing that. Okay, I see it coming down. I see it going up. I'm going to change my window just a little bit. I don't think I need to go all the way up to 20. I'll go like that. We want the shortest distance possible. That sounds like a minimum happening right there. So second trace, 3. To the left of it. Now I'll go to the right. Gives me the ordered pair 6.5, comma 2.6. So our minimum happens at 6.5, comma 2.6. Again, it's x comma y, but we didn't use y in our equation or in our function. We used d, so that second number represents the distance. And since it's asking for the shortest possible distance, the y value is what you're wanting, 2.6. All right, last one. A rectangle has its base on the x-axis and its two upper corners on the parabola y equals 6 minus x squared. You'll notice that it just says the x-axis. It does not say only the positive x-axis. So when we look at our picture, it goes up 6, and then it's a parabola opening down. Now in order for our rectangle to have its two upper corners on the parabola, or excuse me, for our rectangle to have its two upper corners on the parabola, one corner is going to have to be in the second quadrant, and the other corner will have to be in the first quadrant. Now, my picture is not drawn very well, but it should actually be centered about the y-axis, okay? So it should be symmetric, because a parabola is a symmetrical shape, which means that we have to deal with the fact that from the origin to this vertex or corner is x, and the origin to this corner is also x. So in this case, the entire width of our rectangle is actually 2x. Since height-wise, it only exists on the top half, this is just going to be y. So where we normally say that area is length times width, this time we'll say, okay, it's y times 2x, or 2xy. The problem being we don't want two variables, we just want one variable here, and the variable that we want is x, which means we need to get rid of y. And we'll replace y with this 6 minus x squared. So our equation is going to look like a equals 2x times 6 minus x squared. And you can leave it like that, that's fine, or you can write a of x equals 12x minus 2x cubed. X is the only variable in your equation, so you're done. On part B, find the largest area that can be enclosed by the rectangle. Well, another word for largest is maximum. So we'll graph this. It's a cubic, so we would expect it to have the top of a hill, a maximum, what we're looking for, and see what we find. Excuse me. Okay, so in your y equals, type in 12x minus 2x cubed. gonna do zoom 6 just to see what that looks like. So my maximum's happening there. I'll go up just a little bit so I can get a better idea for it. All right, making my calculator find that. We'll do second, trace, 4. There's my cursor, it's to the left. Now I make it go to the right. Enter one more time. I get 1.41, comma 11.31. 1.41, comma 11.31. Close that out. So again, all right, this was the max, sorry. Happened at 1.41, comma 11.31. Since it's asking for the largest area, that would be your second value. So the maximum area is 11.31 units squared. All right, that is the entire paper done for you, so you should have all the answers down. You need to turn it in now. Make sure your name and number is on it, please. And then watch the second video that says Mrs. Poe, Advanced Algebra, Section 1.7, Variation.